Hello students, let's talk about three terms that are sometimes incorrectly used interchangeably. So the three terms that I'm referring to are temperature, thermal energy, which is also known as internal energy, and heat. These are not the same terms. So the one that you're probably most familiar with is this one, right? Temperature. So what is temperature? It's how hot or cold something is, right? It's how hot or cold something is based on some standard scale, and those are the temperature scales. So we are familiar with a few of those scales, like degrees Fahrenheit. That's the one that we use for today. Currently, right now, it's about 50 degrees Fahrenheit outside. And so I know what that temperature feels like because it's related to a particular scale that we're used to. Most of the world doesn't use Fahrenheit, they'll use Celsius. And scientists also use other temperature scales. One of them you've probably heard of, which is called Kelvin. There's no degrees in Kelvin, we just say Kelvin. So any of those or many other temperature scales are used to measure how hot or cold something is. And notice down here I have written it's average energy per molecule, right? So it's based on the average energy per molecule. Temperature is not a measure of heat, and sometimes even in videos that you've watched it will say that temperature is a measure of heat. Heat is a type of energy. Heat is a transfer of energy. It's when thermal energy moves from place to place or from substance to substance based on differences in temperature. Most of the country will measure heat energy in joules, just like we've done before. That's the metric unit. We're a little different in the United States, so what do? We like to mess it up, and we will often measure heat energy in something called calories. And tragically, the calorie that I'm referring to is a little different from the calorie that you're used to on food items. That's actually a kilocalorie. The other term that sometimes is confused is thermal energy, right? And thermal energy, which is also the internal energy of a substance, is the total energy of all the particles, atoms or molecules or whatever it is that's making it up. That's what thermal energy or internal energy is equal to. This is also a type of energy, so it's going to be measured in joules as well. Or, in the United States, of course, we still use calories. So these two, heat and thermal energy or internal energy, these are measurements of different types of energy, and we use joules or calories in the United States. And then we've got temperature, which is an average energy per molecule. It's how hot or cold something is, and we do not measure this with a energy unit. We measure it with a temperature unit on any of the temperature scales, like degrees Fahrenheit or degrees Celsius or Kelvin, and there are others as well. Rankine is one of them. So let me just show you a little bit more about how these three terms go together, and then I'll show you how to do a temperature conversion. Okay, let's talk a little bit about these three terms again. We've got temperature, and then we have heat, and we also have thermal energy. So the way that we can look at this is, let's say that I have some material right here, like this. And we'll just call this substance number 1. And let's say that let's change the color of that, we'll make it a little bit better. Let's say that this over here is hot. And then we've got over here substance number 2. And substance number 2 we'll say is cold. And so what happens is that we have these two things that are either in contact or a way to go between them, and we'll end up with the thermal energy goes like this, right? It always goes from hot to cold. So we've got something over here that's hot, we've got something over here that's cold, and so we have our different temperatures. And in fact, maybe over here we've got something that's like body temperature. We'll say this is 37 degrees Celsius. And then the cold, maybe we'll say this is 5 degrees Celsius. We have these differences in temperature, and thermal energy will flow from hot to cold. And that movement of thermal energy is what we call heat. So the heat is the movement of thermal energy from a hot object to a cold object. Okay? Now, the other thing that we want to talk about is that we can do some temperature conversions. And when we do temperature conversions, we typically will go between Celsius and Fahrenheit, or may also include in those conversions Kelvin. So how do we do that? So if I have something that is in degrees Fahrenheit, and I want to convert this to degrees Celsius, then what I need to do, the steps for this, number one, is I have to subtract 32. And then step number two is I have to take that number and then I multiply it by 5/9. So that's our first conversion. We may also need to go from degrees Celsius back to degrees Fahrenheit. And in this case, I would kind of do the opposite, not a plus sign. This is step number one. The first thing that we would do is we would take our degrees Celsius and we would multiply it by 9/5. And then once we have that number, we would add 32. And another conversion that we can do is we can simply take, if we have our degrees Celsius, and let's say we need to change this to Kelvin. Notice I did not say degrees, right? Kelvin does not use the little degree sign. Kelvin is an absolute temperature scale, which means it can never be negative. So in order to do this, there's really only one step that you would have to do when you're doing this conversion. To protect Kelvin from never being negative, you would just simply add 273, and that's it. And if we wanted to go back from Kelvin to degrees Celsius, there's only one step that you'd have to do. You subtract 273. And the reason that we do this is because a degrees Celsius and Kelvin are exactly the same size. However, Celsius and Fahrenheit are not, right? A Celsius degree is actually bigger than a Fahrenheit degree. So one of the ways that we know this is if I were to draw some temperature scales over here. I'm just going to draw a line that goes down like this, and these are not going to be drawn to scale. If this is my degrees Fahrenheit and this is my degrees Celsius, and we'll make this Kelvin, then the bottom temperature, all the way like this would be absolute zero. So that is the bottom of the temperature scale. So what numbers correlate to that on these scales? Well, for Kelvin, it's just zero. For Celsius, it's negative 273 degrees Celsius. And then for Fahrenheit, it's negative 459 degrees Fahrenheit. And I'm not putting the degrees here because it's indicated on the top of the scale. If we make another comparison, let's just go across again, and we'll use kind of the standard number. Let's say that this is where, I'll need to give myself a bit more room here. This is where water freezes. Well, what temperature does water freeze? Well, it would be 273 Kelvin. Or, I missed over here, it would be 0 degrees Celsius, or it would be 32 degrees Fahrenheit. And then we'll just look at one more temperature so we can make this comparison. Let's look at water boils. So when we do this water boils temperature, it would be 373 Kelvin. It would be 100 degrees Celsius, and it would be 212 degrees Fahrenheit. And let me just make a little note here. Let's pick about this color. There's 100 degrees between the freezing point of water and the boiling point of water on the Kelvin scale. There's also 100 degrees on the Celsius scale. However, on the Fahrenheit scale, there's 180 degrees in here. So that's why we have the fraction on this side when we have to do the conversion between Fahrenheit and Celsius and back again. Right? The reason that we would do that is because 1 degree Fahrenheit is smaller than 1 degree Celsius. Okay? So this is how we do the conversions. Let's just do one as an example, and then I think you'll get the hang of it. The example that we're going to do is we'll use body temperature as one. So what we'll do is we have our body temperature of 98.6 degrees Fahrenheit. And what we're going to do is we're going to take our degrees Fahrenheit and we'll change that to degrees Celsius, and then we'll just do one more and we'll change that to Kelvin. So we'll do 2 conversions. So if I have degrees Fahrenheit here, and I go from Fahrenheit to Celsius, the first thing I have to do is subtract 32, and then I take that answer and I'll multiply it by 5/9. So I'll write my 98.6, I'll subtract 32, and I have 66.6. I'll then take that number and I'll multiply it by 5/9. And when I do that, I end up with 37. And since I'm going to degrees Celsius, I'll just write degrees Celsius. So that would be my answer for the first part. 98.6 degrees Fahrenheit is the same as 37 degrees Celsius. So the next step is to take our 37 degrees Celsius and change that to Kelvin. So if I go from Celsius to Kelvin, the only step I need to do is add 273. So I'll take my 37 and I'll add 273, and that will give me 310 Kelvin. Remember, there's no degrees sign on the Kelvin scale. And that's it. That's how we do these conversions. It's as simple as that. Let me know if you have any questions.